Hello there, my name is Mingkai Guo. I'm a senior electrical engineering student at San Francisco State University. In this video, I'm going to introduce you to my joint robot project, which is following the lead of Dr. Azadi in Engineering 415 Mechatronics course. In this class, we're using Arduino engineering kit to explore and experiment. This kit is designed for engineering students who want to challenge themselves and develop their hands-on skills. There are 3 different types of robot that can be built by this kit, and they are a joint robot, a mobile rover, and a self-balancing motorcycle. All 3 robots can be programmed by MATLAB and communicate through an Arduino board. A motor carrier is used to communicate with DC motor and servo motor, and a IMU shield is used to detect data from 3 dimensions. The joint robot project allows us to create a 2-dimensional robot that can draw on a vertical surface. With the MATLAB coding, the robot is able to either draw a prepared image or using any additional camera to capture and draw the image. The joint robot project has 2 strings connect to 2 pulleys, which lets the robot hang in a vertical direction. The other side of the strings connect to 2 DC motors, which control the robot's position. The DC motor here is a 100:1 ratio geared DC motor with a magnetic encoder. This encoder can get feedback information about the rotational speed and spinning direction. 2 markers are controlled by a standard servo motor, which can rotate from 0 to 180 degrees. When the servo motor is at 90 degrees, those markers are raised without touching the joint board. When the servo motor rotates to 0 or 180 degrees, one of the marker is going to go low and touch the joint board. The microcontroller that's been used here is the Arduino Maker 1000, which includes a Crypto chip and a Wi-Fi module for secure communication. The Maker 1000 board can carry a 5-volt reference voltage, and the board has 7 analog pins and 15 digital pins. All pins can transmit or receive voltage from 0 to 3.3 volts, and they can also be used to communicate with external components. Like, for example, the Maker motor carrier that used here. This carrier can control both servo motor and DC motor at the same time. In this project, we are using 1 servo motor which is connected to servo output 3 and 2 DC motors that are connected to motor 1 port and motor 2 port. A USB connected webcam is also used here to capture the current image and send it to MATLAB. The Arduino website provides a full detailed tutorial on how to build each project. The joint robot has 7 different texts that guide you to learn how to control robots through MATLAB. Text 1 lets me learn how to raise and lower the marker by adjusting the values of servo motor. I found my servo module that can lower either marker and save them in a data file. In text 2, I took a measurement of the base distance, which is also distance between 2 pulleys. A provided function called initial position was created to calculate the robot's starting position using the length from pulleys to DC motors. The xy to const function is also provided, which can convert xy coordinate to encoder const so that the DC motor will know how many rotations they need. In text 4, I measure the height of the joint board and combine it with base measurement so that the drawable region limit can be determined. In order to let the drawing robot do its work, I have to either prepare an image or use the webcam to capture the image. For a prepared image, I have to load it into MATLAB first and convert it into a grayscale image. Then use the grayscale image to convert it into a bannerized image, which only contains the colors of black and white. Next, use the banner array image to generate a single list of pixels and convert them into a cell array of pixel segments. By checking if all segments are adjacent and connect them with minimized gaps, a connected pixel image will be formed. Using this image to find the maximum and minimum pixel position would allow you to change the image scale so that it can fit my drawing board. For a live image, I used the webcam that included in the kit, connected to my laptop and specified the device name and number. Then use the snapshot command to activate the camera and capture the current image by pressing the Enter key. Now the MATLAB can process the captured image as a prepared one. Now let's show you the first demonstration of my drawing robot drawing a MATLAB logo. And now let me show you my second demonstration of the drawing robot drawing a captured smiling face. Thank you for watching, and this is all for this video.